Hi everyone. Looking at more on logs and what we can do, this is more what we'll see in Western Australian exams at the methods level. Very common to see these type of concepts just repeated often in the exam papers. Be the same in New South Wales and in most places in the world actually. Let's have a look what we have here. A lot of people think because of the index law with logs that they can move that index 3 to the front, but you can't, because it's not in the total control of the X and Y. It's only controlling, I call it sitting on, the 3 is only sitting on the X. And because it's only sitting on the X, I can't just move it to the front. Over and over again I'll see students write that. And then they'll go on and use more log laws and they'll do well with what's after that. But that is incorrect. You can't move that 3 to the front. It's actually, the log itself has a bracket around it here on the inside to say the x cubed and the y are contained on the inside of the log. They're under the control of that bracket. Everything in maths have brackets around it. When we write a square root, it has a bracket. So if I write the square root of 7, it's actually the square root of bracket 7. If I write a fraction that's 3 plus 4 over 5 plus 6, it actually has a bracket here and a bracket there. If I write 3 to the x plus 1, it actually has a bracket around those there. So back to the basic concept is, the section inside the logs, a lot of people will always write the brackets there. In the context here, it doesn't need the brackets, so a lot of people will always write them. Have a look at what's going on here. This is what I talked about, the potty rule. A plus on the outside is a times on the inside. So you can also call that typo, but I really don't want to think typo because I just think potty. The moment I have potty in my head, times on the inside is a plus on the outside. So a times on the inside, there's your times on the inside, under the control of the brackets, becomes a plus on the outside. So there's my plus. It's not contained within the bracket of the logs. So the first bracket would be an x cubed, and the second bracket would be a y. If we started with a base of a, it remains the base of a. So all we've done is divide those two sections out into those there and put a plus in between. If you don't understand the potty rule, go back to the previous videos that I've made and have a look at those. Now I can apply the index law. Here with this little section, I can put the 3 to the front, and I've got 3 of that log that I had here in the first place. So really in a way, it's like here's a bracket around all of that. Some people would prefer to write the bracket here and put the 3 on the top. It gets confusing, that's why I don't go to too many brackets. Okay for me and for a lot of people, but it confuses people. So that's a 3 of a log of x base a plus a log of a y base a. So on this question we don't know what x is, we don't know what y is, and we don't know what a on both of those are. So do we see a purpose for this as yet? No, this is just learning how to manipulate expressions. That will be useful later on. So this one here, lots of students just jump in and they put the 2 at the front because they know there's an index law that says put 2 at the front. It's not sitting on the bracket with all of them. It actually has a bracket around all of this here. That 2 is contained within there. So what we need to do is get these terms here, these numbers and variables here, outside of the bracket. How do we do it? Back to the potty rule. A times on the inside is a plus on the outside. So I'm going to have a plus there. I'm going to have the log. I'm going to have the log. And this has 2, I always want to call them sections. It's got a 5 and it's got an x squared. So the 5 goes there and the x squared goes there. So the 5 goes onto the first one and the x squared goes onto the second one. We started with a base of 5, so we still have a base of 5. So the bases stay the same. Let's have a look what happens here now. Back to this rule, the log of 5 base 5. 5 to the what is 5, and the answer to that is 1. So if we had the log of 3 base 3, it's 1. If we had the log of 4 base 4, it is 1. This one, I can move the 2 now, which is sitting on everything that's inside. I can now move that to the front as 2 a log of x base 5. Can I do anything further with that? No. Very common for students to get this right and not go to the next step. That's a log of 5 base 5. There are so many intricacies in logs that makes people up, and your brain needs time to take it in. Let's have a look at this one. We need to get rid of that. Because the 4 is controlling everything inside, I can just put the 4 to the front. They can just go to the front there. I could put brackets in if I wanted to, and I've got that there. So the 4 up here, if it's in control of everything, goes to the front. Here it wasn't in control of everything, it was controlled by that multiplication. Here it was controlled by the multiplication. So we had to separate out first because of the multiplication. So once I separate it, I can then do other things with log laws. So this one, the 4 can go to the front. Now here's where it gets a little bit confusing because we've got 4 multiplied by all of this. I'm going to put the square brackets to hopefully make it clearer. Now we're back to the potty rule. Here we have the potty rule. There's our multiply. So our times on the inside control of the log, within the bracket of the log, even if we don't have log brackets written there. Potty rule, the times on the inside becomes a plus on the outside. But this extra 4 at the front controls everything. So if I had a major calculation here, everything there is going to be multiplied by 4. So how do I say everything? Brackets. In this case, I'm going to go square brackets. So there's my potty rule, the times on the inside, there's a plus on the outside. So there's my plus, there's my log and my log. I got 2, mathematically I shouldn't call them sections. There's a 2 there, and there's an x there. So they like section out though. I will talk about that way doing sections. Had a base of 2, so it stays as a base of 2. So what do we have now? Back to over and over again. The log of 2 base 2 is 1, the log of 3 base 3 is 1, the log of 4 base 4 is 1, the log of a base a is 1. Anything for the same base. You could go stupid and even say the log of 7.3 with a base of 7.3 is 1. Oops, and I wrote 3, so it's a 1. Easy to write what I've been saying. So the log of 2 base 2 is 1, and that's just a log of x base 2, which we can't do anything more with. Now if I expand the bracket back out and you go, oh, could I have done it other ways? There's other possibilities. 4 times a 1, and I got 4 log of x base 2. Could I do more with that? I could put that 4 back up there again. So if you have further understanding, you get more familiar, there are other things you can do with a log, depending on what you want to do with it next. Okay, here we go, last one. So this is the log of xy. Remember, the line on a square root is actually a bracket. So everything, if you type it into a ClassPad calculator and some of the scientific calculators, it may come up with a bracket there. So here we go. That then, as a square root, becomes a half power. Because the half power controls everything inside, I can move it to the front. So now I have a half of the log of xy. All with a base of x. I've forgotten to write my base. Now, can I go a step further? This is typical of a Year 12 WACE exam in Western Australia. Give you something like that. People get to there, think they're finished, and they can't get full marks for it. So, again, I'm going to do, there's a multiplication out here. It's not a multiplication on the inside. This half will control everything, so I'm going to put a square brackets there to make it a bit clearer. Now I've got the potty rule here again. So times on the inside, it's actually the reverse of the potty rule, but I still just call it potty. Times on the inside is a plus on the outside. So there's my plus on the outside. So the half controls everything, controls whatever happens here, so it goes to the front. And then I've got these 2 bits here. So I've got a log and a log. I can write the x first, I can write the y second. Don't forget we have a base of x. I picked the base of x on purpose because I wanted to see what happens with this part here, because it actually works out to be that in many situations. Now I've got a half of the bracket, and the log of 3 base 3 or 4 base 4 or x base x is 1. X to the y will give us x, and it's x to the 1. And then the last bit is the log of y base x. Then if I want to, I can expand that out to be a half plus a half of log of y base x. Thanks again.